Great. Well, thank you all so much for joining us for Beachcombing for Signs of Wildlife with the Mass Audubon. From the rolling dunes of Cape Cod to the rocky North Shore, the beaches of Massachusetts offer unique opportunities for life to converge. Learn how to read the landscape, search for wildlife, and understand the ecological relationships between species you may be familiar with. How do horseshoe crabs, least tern, ribbed mussel, and people interact on the coastline. Explore best practices when combing the beach in search for wildlife clues, and leave with recommendations from Mass Audubon teachers and naturalists on the best places to explore. And this presentation is led by Douglas Lowry, who's the adult education specialist for Mass Audubon's Southeast region. He's also a senior field instructor for the National Outdoor Leadership School. So all 70 of us or so, let's give a big virtual round of applause to Douglas for joining us here today. And Douglas, you can take it away. Thanks so much.
You're welcome, Robert, and thank you for that introduction. I'm very excited to be here this morning. I love the fact that we have folks from all corners of the state and beyond. New Mexico. We'll do our best to, we'll get nostalgic with you. So it's a pretty fact-packed presentation, so the pace will go pretty fast. We've got about 60 slides here, so I won't spend any more than a minute on some of them. So off we go. Here is an agenda, and we'll stick to this pretty closely. Some of it will overlap. So we're going to start with intertidal habitats and communities, kind of describe the differences between some of the unique coastal environments that we have along the coast. We'll provide a few tools and resources that can really help enhance your experience as you visit the shore. And then we'll go through a number of photographs of what you're likely to find and why the things you're going to find are so special. As you can imagine, there's some really unique adaptations with the creatures and plants that we find along our coastline. And then we'll finish by talking about some of the places that along the Massachusetts coast where you might find some really great beachcombing. So off we go. We would like to start though with an acknowledgement. And we at Mass Audubon acknowledge that Mass Audubon's wildlife sanctuaries are located on the traditional, contemporary, and unceded territories of several indigenous nations, including the Massachusetts, the Mohican, the Nauset, the Nipmuc, the Pennacook, the Pecomtuck, the Wabanaki, and the Wampanoag. These lands were taken from the indigenous people, creating a legacy of trauma that persists to this day. We acknowledge that indigenous stewardship of the land we now call Massachusetts kept its ecological communities vibrant, strong, and interconnected for thousands of years. But far from being relics of the past, indigenous peoples, including the 37,000 individuals who currently reside in Massachusetts, are still at the forefront of environmental protection, ecological stewardship, and climate mitigation. I often start my presentations with a quote that is dear to my heart, and Rachel Carson's one, I think, just an amazing source for these. So she, in every outthrust headland and every curving grain of sand, there's a story of the earth. So what do we describe as a coastal environment? Well, here's some examples. So we're down here on the South Shore and we're looking down at Duxbury Beach, and it's a 7+ nautical mile barrier beach. And it is a stalwart protector of both the towns of Duxbury and Kingston. And it's joined by another barrier beach that helps this large bay, Plymouth, Long Beach and Plymouth, and that protects Plymouth as well. And so you can see a little bit of that on the right-hand side on the chart. Plymouth beach coming up from the center of the photograph going north. And what these barrier beaches do is protect the inland waters from winter storms primarily, and the community, not only the bay, but the communities in the bay, along the bay. And they provide that protection that they provide, offer an opportunity for salt marshes and mud flats to start establishing. And that's often where we find ourselves when we're exploring coastal tidal areas. So we will talk about that in more detail as we go. But on the chart, if you look at the areas of blue, charts will measure the bathymetry of the ocean floor. In other words, the areas that are under sea. And so they have depths rather than heights, like a topographic map. And those blue areas are areas that of alike depths. And then you get into the green areas, and those are areas that are awash at low tide. In other words, if the tide was out, all these areas of green would be exposed. And a lot of them are mud flats, but a lot of it is salt marsh as well. So when we define beachcombing traditionally is the very leisurely walk down the beach and see what you see kind of thing. But there's other ways to explore coastal environments as well. You can explore the salt marsh habitat specifically. You can walk the rack line, which is essentially the flotsam and jetsam that is dispersed up on the beach from the latest tide. Or you can go tide pooling where it's appropriate. A lot of the rocky shorelines, especially on the north shore of Massachusetts and a little bit down in Buzzards Bay, lend themselves to have some great tide pooling where there is the absence of sand essentially. And so the intertidal life is a little different. You'll see that there's some shared community members in both habitats, but tide pooling is a whole different subject. And then there's also exploring the mud flats, and we'll talk about that as we go. So this is a generalization, but we're looking at the Massachusetts coastline, and you can kind of divide it up 4 ways. So we have barrier beaches, which we just described as Duxbury Beach being a great example of it. And so a lot of our out-facing, ocean-facing beaches are barrier beaches. And those are essentially all part of the geological history of glaciation. They're all parts of those terminal moraines that you probably remember back in middle school geology. Then we have what we call mainland beaches, things that they're more stalwart, they're certainly less fluid than our barrier beaches. They're well established. They are not subject to erosion as much as, or offshore currents as our barrier beaches. We also have these bluff with linear beach. And if you're familiar with the Cape Cod National Seashore up in Truro and around the corner into Provincetown, you see this very cliff-like geology that's basically sand that drops off and then spills out into the ocean in a kind of what we define as a beach. And then rocky coast, again, up on our North Shore, Rockport area, and then a little bit here and there. And you can find pockets of this. Cohasset down on the South Shore has a little as well. Another thing we're looking at with coastal viewing is that depends a lot on the season. So here's a generalization. Our winter storms change the profile of our beaches by having more dynamic wave action. And so as winter storms come in, they pack more of a punch, and they pull more of the fine mineral sand and soil away from the beach, exposing the rocks. And as summer comes along, those waves are more gentle and they have a tendency to deposit some of the finer grains of sand up on the beach, and the receding wave doesn't pull it back out into the ocean like it does in the winter. So in the wintertime, many sandy beaches that you're familiar with in the summertime might look drastically different. But the creatures there are all pretty much the same that you see in the summer. They just have to adapt a little differently. And so you can overturn rocks and find crevices and that kind of thing, and find the same species of animals that you would in the summer. Another consideration when we're tide pooling or beach combing is the tides. Yes, and Massachusetts has diurnal tides, which means we have 2 cycles. And so a tide cycle is one high tide plus a successive low tide. And due to land masses in the geology of our coastline, the movement of water around the earth is impeded in places. And so the resulting tide cycle pattern can really depend on the geographic location. So there are times when on the ocean side of Massachusetts, we might have a 12-foot tide differential between low and high tide. If you sneak around into Buzzards Bay, at the same time we're having a 12-foot tide in, say, Boston Harbor, they might be having a 3.5 or a 4-foot tide. And that's all about filling in these vacuums at different rates because of the volume and the shape of the geography. However, everything is subject to the cycle of tides. And so there is here a low tide that rises fairly slow to start, speeds up, slows down, and then recedes back down to a high-low tide. The next tide comes in, slows down towards the end of the cycle, and becomes a high tide, a high tide. So it gets a little confusing, but the things to remember is that the lower the tide, the more access you're going to have to intertidal habitat and the creatures that live there. So here's a little rule, if you will. It's the rule of 12ths. So let's use a 12-foot differential as an example. So it's 12 feet from low tide to high tide. And in the first cycle of that tide, that 6-hour cycle, as the tide rises from nothing and then up to the highest tide. In the first hour, 1/12 of that volume of water will come in. In the second hour, 2/12, and so on and so forth. So tides start off very slow as they come in and then move very fast towards the middle and then start dropping back down towards the end. And so if you look at either end of those tide cycles, that's probably the best time to go visit for tide pooling and mud flat. This is a picture from our Wellfleet sanctuary, and it's a boardwalk that goes through a salt marsh out to the barrier beach. And yeah, keeping track of the tides can be pretty consequential. So let's talk about some of the unique qualities of the things that we find in our intertidal zone. So these are things that creatures have to deal with as they have chosen to live in this environment. Lots of salinity, okay, because of the tides, the salt water comes in and out. We have the tides going up and down, and so we've got salt and freshwater influence. Often our salt marshes certainly have to have a freshwater source. We have extreme seasonal temperatures. You can see them there. And then the seasonal water temperatures as well. Sometimes there's very little shade in intertidal zones. And then you are subject to predation from all sorts of areas, land, sea, and air. There's an intermittent food supply. If you are a filter feeder, you have to wait it out until the next tide comes in. You are processing toxins. A lot of agricultural and residential runoff, mostly in the form of some of our nitrogen, and then we have sea level rise in the mix. If you are a mussel that is harvested, you might get over harvested. And then we have the introduction of non-native species. That has really made a difference in a lot of our habitats. So there's a lot of things you've got to be prepared for in changes on a daily basis. There is an immense amount of resources out there for exploring tides. You can get as detailed as you want. We produce this and others. There's some great fold-outs, laminated fold-outs on the market. We're not the only ones that do it, but the Beachcombers guide on the far right is a great one source kind of resource. But then there's some great books to read if you want to get a little more of the backstory for some of these creatures. One of the best ones is the Field Guide of the Atlantic Seashore on the upper left-hand side. And that is one of the Peterson guides. Unfortunately, it's out of print, but you can still find used copies here and there, and certainly on the internet. It's a great resource. We'll reference it later on. Other things you might consider, you don't need these, although I would strongly suggest some sort of sunscreen or appropriate clothing and hat. But a tide chart would be really handy, or at least know what the tide's doing. Tray or bucket filled with a little bit of water can give you an opportunity to isolate some of the live creatures and put them in the bucket for a while for observation, long enough to get an idea of what you're looking at, and then obviously being respectful and putting the specimen back into the same spot you found it. But yes, finding a crab and getting it into a bucket and watch it look up close using a magnifying glass is just one of life's treasures. Small container to isolate smaller specimens can be helpful, and a scoop can be helpful as well. And then, like anytime we're going into nature, if you will, we want to think about leave no trace outdoor ethics. And there are some ones that are specific to traveling around our intertidal zones, especially things like dunes and staying off of dunes and vegetation on dunes. This is probably pretty universally understood. But the one thing is, there's a temptation to bring back treasures. And so you gotta be careful not to fall into that and start taking all these specimens home. Often you regret it because they do start to smell, many of them, because of the nature of the intertidal or origin of these creatures. And so here's some raccoon. This is down on Martha's Vineyard at our Felix Neck Wildlife Sanctuary. And there's some green fleece, which is actually an introduced algae or seaweed along our coast, and some raccoon prints. Now we also probably know a lot of these species here, but let's do a little bit of dividing a couple of terminologies here. So we have univalves, like this whelk here, that only has one chamber. And so here's another generalization. All our mollusks or shells have a calcium carbonate makeup. And so some shellfish choose to be a univalve. And if you are a univalve, you usually, your soft body is protected by this shell, and you are going to look very similar to a garden snail. So you're going to have a foot and some antennae, a siphon, that kind of thing. And we'll show you in more detail what that looks like. Or if you're a bivalve, you have two halves, two shells that hinge, and you might either filter feed or siphon feed, or you might self-propel like our scallops. So we'll divide that up a little bit as well. So here is our bivalve, and bivalves, like our fish, breathe through gills, and they're filter feeders, and they gather food through gills. Some bivalves have a pointed retractable foot that protrudes from the shell and digs it down into the surrounding sediment. And so it enables the creature to burrow and to hide. And they're pretty good at this. They can move a lot faster than you might think. If anybody has seen a razor clam bury itself, you will appreciate just how fast these clams can bury. So bivalves even make their own shells. An internal organ called the mantle secretes calcium carbonate so that the inner invertebrate, as the inner invertebrate grows, the outer shell provides a roomier home. They have an amazing ability to filter seawater in large quantities. And so a lot of our bays are much cleaner because of these bivalve beds. And so here are some of these species, and I bet many of you already knew a lot of these. So razor clams, and we'll talk about a lot of these in more detail as we move forward here. But razor clams, surf clams, quahog, soft shell clams are mollusks that will bury themselves in the mud and filter feed using siphons. Then we've got oysters that are colonizers, rib mussels, which are colonizers, and they have a tendency to stick to the salt marshes. And blue mussels are, again, colonizers. And you're going to find them in more of the rocky areas or anywhere there's a pier that they can attach themselves to. So here's an example of one of our univalves. This is a dogwinkle, very much related to some of our whelks, and what its claim to fame is that it's shared with moon snails and some other univalves is, there we go. It's got this foot that comes out that can move around. The operculum is attached to that foot, and it's a trap door. So as the foot retracts back into the shell, that operculum closes tight and prevents any moisture from leaving the shell, and also protects the shell from predation. Then we've got these tentacles that come out that are basically feelers, as all tentacles are. It's got a siphon. It also has a proboscis. And what's pretty amazing, it's got eye spots. What's amazing what that proboscis does, and inside that proboscis at the end is called a radula. And a radula is it's a drill. And so what dogwinkles and moon snails can do, among others, is to attack another clam or mollusk and slowly drill a hole into the shell of its prey. Some will use enzymes as a way to make that drilling process a little more efficient, very much like you would oil a drill bit if you were using a drill bit into metal. And it also, another benefit of that enzyme is it will start to, once the hole is through, those enzymes will also help stew, if you will, the prey. and then it's easy to basically suck up the nutrition of its prey. Here's an example, and maybe you've seen this walking on a beach. You might find a hole that you might think is random. It's not always right in that particular spot, but often it is, because that's where the hinge is for shells. The holes can be anywhere, but often they're up to where the hinge is to weaken the hinge. Other things you might see associated with whelks are the whelk egg cases. And so here's an example of just a few of them. They look like, well, they're described as rattlesnake-like for the channeled and knobbed whelk. It's a string of these chambers, and obviously this looks way bigger than this whelks can possibly contain inside the shell. Well, like many things that are exposed to water, it will expand quickly. So it isn't developed inside the shell as large as this example on the left. But each one of those chambers will contain young whelks. And that is one of the many egg cases that you'll find. Here's the moon snail. This is a fairly large snail, and this particular, this is another snail with a radula. This one works a little differently in that it has a huge foot, and when it comes across its prey, it'll envelop the prey completely, and it takes about 3 or 4 days, but it will drill the same manner as the dogwinkle. And what's another unique quality of moon snails is that they create these egg cases in the upper left-hand side you see on the slide. They basically use like a mucus that they bind sand particles with and interject their eggs, thousands and thousands of eggs in this cone. And if you walk along the beach and see these, you'll be surprised at how resilient they are. You could even pick this thing up and handle it a little bit if you were gentle, and it won't disintegrate. And like so many other things in nature, there are other whelks that will find this as a perfect place to lay its eggs. And so sometimes you'll invert these moon snail rings, if you will, and you'll see other eggs attached to the underside. Just another whelk being efficient about finding out a spot. These are slipper shells or boat shells, and these are unique in that they often colonize on top of each other. So they will stack on each other, and they are filter feeders. You would think like they're similar to a chitin, if you know what a chitin is, but they don't graze. They filter feed by just lifting their body off of the substrate that it's attached itself, and whether it's a rock or a horseshoe crab or something other living organism, or if it's stacked on another slipper shell, they just raise themselves up a little bit and let the water flow through their body where they pull out nutrients in the water. Scallops swim. They have amazing abilities to have these valves, which create vacuums, and when they basically use the hydraulic power of displacing that water in those valves, they'll propel forward. The siphons basically are on the hinge side, so the scallop will move forward through the ocean. Scallops also have many eyes on the edge of their outer shell, bright turquoise. If you ever see them in the water, it's pretty amazing. Then we have the long neck or soft shell clam. We often call this a steamer. if we are so inclined to eat shellfish. And so it has a foot, and it also has a siphon. And like many of our clams, the siphon has two chambers, one intake, brings in water, pulls the nutrients out, processes it through its stomach, and then dispels the seawater afterwards. The razor clam, again, this is our famous razor clam that can bury itself really fast, and its ability to create its own quicksand is the reason why it can do that. So it essentially, it's got a really strong foot, and it pulls in water and then ejects the water out the split of its shells, and that essentially turns the sand that's immediate to it more like quicksand, because it's now got water in it, and so it's more efficient to bury itself. So you could watch a razor clam go from sitting horizontally on the top of the mud, and as long as it's got water to deal to work its valves, if you will, it can move in about disappear in about 4 moves pretty quickly. And here you can see the great photo by a friend of ours, Amy Quist, and you can see those 2 chambers on the top. We're looking straight down on the top of this razor clam, and one of them is closed, one of the chambers is closed, and the other one's open. Other things you might find are shells riddled with holes like this, and that's because we have sponges along the coast as well. And we often don't see sponges until the tide differential is quite large, and you have access to some of the lower tides in the season. So some of those spring tides would give us depths that we would be able to explore a lot of sponges we wouldn't otherwise. In these holes are created by the boring sponge. And this is Peterson's guide here, and the boring sponge illustrations up to the top there. And this is what a boring sponge looks like in real life. And it essentially feeds off the calcium carbonate. Along more of our rocky coasts, you can see there's these zones of predation, but also zones of where the tide comes up and what species thrive at each level. And it's you can actually see this when you visit rocky shorelines. What you see will look very similar to this illustration, and that distinct of isolated layers. So some of our bivalves are colonizers. And so these are young blue mussels, a colony of blue mussels that have found a way to attach themselves to this established barnacle colony. And so these mussels at some point are spat, if you will. So they are free swimming as young. After they're hatched as eggs, they're free swimming, and they will swim around until they find a colony that's established, or they'll establish their own. And once they start to grow, then they have this ability to create these Bissell threads, which are anchors essentially, that they can control. They can shorten or lengthen them if they need to move around a little bit. And so that's pretty incredible. So again, another filter feeder using a siphon. And this is a photo of a razor clam with a blue mussel starting to colonize this razor clam. And you can see those Bissell threads with the anchors on this photo. Barnacles are an animal of a different color. They are primitive, but amazingly adapted to a lot of the zones in the tide cycles. They pretty much will grow on anything that isn't moving. So you see barnacles a lot on piers, on the pillars of piers, and certainly on rocks and boats. And the hulls of boats also have a lot of barnacles. And they too, as small young, will free float and swim around until they find a colony, and they'll attach to the substrate and then start creating, with calcium carbonate, this volcano-like looking structure with a beak. And that beak can close up tight, and the barnacle can withstand long periods of time without being underwater. So pretty fierce creature, actually. And it filter feeds with its cirri. We'll jump to crabs, and we will keep it simple here, but here's some generalizations. Crabs have 10 legs, 5 pairs, and one of those pairs are claws. And those claws can be very, very different depending on the species of crab, as we will see. Crabs have exoskeletons, flattened bodies, 2 feeler antennae, 2 eyes on stalks. They are omnivores, and if they live in the ocean, they breathe using gills. Walking crabs have legs designed to walk, and so their hind legs in particular look very much like the rest of their legs, and you'll see the difference when we talk about swimming crabs in a minute. But spider crabs, you can see by the size of their claws, aren't that particularly ferocious. And so they will eat pretty much anything, but they specialize in eating seaweed. And often you see them in sea lettuce beds or grabbing a piece of seaweed as it floats by. And their mouth parts look like a giant pair of shears. And so they're constantly feeding with these smaller front claws things into their mouths. And this is an actual molted shell of a spider crab. Blue crab is a swimming crab. We have a lady crab as well. It's a swimming crab that lives around here. Blue crabs we're going to find more in Buzzards Bay and that area. We do get some on the South Shore. There's no reason why you wouldn't find a few on the North Shore, but they certainly specialize in southern waters here, Chesapeake Bay being famous for them. And you can see they have different hind legs. They have these paddles or swimmerettes, if you will. And so they specialize in swimming. Here's the underside of a blue crab, but this is true with all of our true crabs in that there's a hinge on the back, on the bottom, and the female has a much larger plate there because she holds eggs there, and the male doesn't. So we'll see that in a minute. So these are green crabs. This is one of the invasive species that has found its way and very, very comfortable living in our offshore waters. They're one of our most prolific crabs now, along with the Asian shore crab. This is 3 crabs kind of getting in a tussle. I'm not sure exactly what they were tussling about, but there's actually one under these 2. Here's a green crab female with egg masses underneath that abdomen. What's cool about crabs is that just like when robins return and all the robins find partners and mates, and they go off and build nests and raise young, the young are born pretty much all the same time. And so you can watch their progress throughout the spring and early summer, and all of the young are going to basically mature about at the same rate. Well, the same is true with crabs. And so you often find crab molts, and that's what these are. They're not dead crabs. They're just the abandoned shells of crabs. You often find them to be similar in size, especially their first year. They might molt, depending on the species, they might molt as many as 5 or 6 times before the winter settles in. As they get larger and larger, adults will molt a lot less, maybe once, twice a year. And so they have this life cycle. They start off with eggs. Again, there's a stage where they can swim around. You can start seeing, this is very similar to like our amphibians, our frogs, and you can draw parallels. And then as they molt, what they do is they split the back of their shell, their carapace, and they back out completely. Everything comes out, the claws, the legs, the eyes, everything comes back out. And this is what's known as a soft shell crab. In order to get larger, they have to do this. So once they are backed out, they will absorb about 15% more water in their system to basically bloat, if you will. They'll either bury themselves for a few days or go hide in some place under rocks or in amongst rocks, or eelgrass, for instance, or seaweed forests. And they will spend that time rebuilding or fortifying their shell until they are feel they can come back out and start eating again. They can be very vulnerable in this time when their shell is so soft. Anyway, so this is why you see so many empty shells. Hermit crabs, they will molt, and their shells will get hard, but they have, through evolutionary process, have determined that maybe living in somebody else's shell works better. And so here on the right-hand side, thanks to Noah, on the bottom is a picture of a hermit crab outside of its host shell. And then you can see the illustration and the photo on the top is they back into these shells and use them as fortresses. Those claws can basically pull back in and close up the shell completely with just the claws showing. So it's pretty effective way to avoid predation. And they too will grow larger, and this is why you can see sometimes these tussles or fights over shells. So at some point, hermit crabs need to find a larger vessel, if you will. And sometimes they're lucky enough just to find one, or sometimes they'll have to fight and pull another one out and take over the shell. Here's a lady crab, and you can see again it has those swimmerets on the back. This is a beautiful crab of our shores. Baby lobster. And because of, you probably heard this, the lobsters are becoming rarer along our coastline in Massachusetts. The water temperature is warming up. Lobsters aren't particularly fond of warm waters, or at least our species of lobster. And so populations are moving further offshore to get into colder water, and or they are moving further north. A friend of mine who's a scuba diver and has licenses to scuba dive for lobster says that he thinks the offshore waters of Massachusetts now look a lot like what the waters off of New Jersey shores did 10 years ago, just in the abundance of life and also the species that have shifted further north, and the absence of species that are traditionally here. An amazing beast that many of us know is the horseshoe crab. It's not a crab, not a true crab, but it is certainly a spectacular animal on the earth. And you can see, let's see if we can get a little laser pointer action going here. So here we can see the differences between the sexes or the genders. Females have on their front leg have this type of claw that looks very much like the rest of the claws. Males have this hook so that they can attach themselves to the back of the female during mating. And some of the things that make horseshoe crabs unique is, well, first of all, their age. They haven't changed to any degree evolutionary for hundreds of millions of years. They have these legs that are used as they are trying to walk on land or underwater on the sand. They lift their body with these legs. They drive their shell into the sand or mud if they want to bury themselves. And then these pusher legs open up almost like, well, let's see if you can get my hand here. They'll open up to push against the sand and then close as they move forward, push against the sand, move forward again. Pretty amazing. These are how they breathe, the gills. This is their mouth part. And in detail, all of these legs have bristles on them that help funnel food into their mouth. And these two little claws will also continually move food into their mouth. The Telson looks pretty formidable, but it's not there for fighting or protection necessarily. It could be a byproduct of it, but this is to push them back over on their stomachs if they get knocked around in the surf, which is a fairly regular occurrence, especially in the spring when they're mating. They're often at the water's edge. This one has a bunch of slipper shells on it that we talked about earlier. And then one other thing before we move on is their eyes are incredible. So they very good at detecting variations in light. So they have a compound eye here, and they have several simple eyes along their carapace. Just an incredible creature. Here you go. This is the underside. Again, this would be a molt. This is a female. Females have a tendency to be much bigger than the males generally as adults. And this one, horseshoe crabs are different than our true crabs. Our true crabs, when they molt back out of the back of the body, in horseshoe crabs, the front splits open and the creature moves out forward. Other than that, they're very similar in the way they approach molting. We've got clam worms, all sorts of worms. We have plume worms that build their own little shelter. There's dozens of species of worms that live in the mud that you might see the evidence of. They're a little harder to find, but you can, if you spend enough time, you'll start to see evidence of worms, including castings and holes. Bryozoans are another citizen of our intertidal zones. And here's one that's growing exponentially, jointed tube bryozoan. Here are those whelk egg cases again, but we have, in addition to the channeled or knobbed whelk, we have the waved whelk egg case, which looks entirely different. And then a skate egg, or some people call this a mermaid's purse. And so skates lay these eggs, and they have these little hooks on them so that they get caught somewhere in seaweed, so protected in a seaweed bed or like habitat until they're hatched. And then we're introducing this term rack line. This is basically what the last tide cycle has deposited on the beach. And this can be a really fruitful way to look at the beach and the creatures on the beach, especially after a storm. On the front side of beaches, you get a lot of seaweed and kelp that grows offshore that we don't otherwise see unless it's pulled apart or dislodged in storms. So I would strongly recommend, after we have a storm, even in the summer, to get to a beach and get on the beach side and just walk down the rack line. You'll find in amongst all this seaweed any number of creatures. Massachusetts is home to the Diamondback Terrapin, and it's in the southern part of the state for sure, but there are lots of efforts, including what Mass Audubon's doing here at its Wellfleet Sanctuary, in restoring habitat so that this Diamondback Terrapin, which is basically a denizen of the salt marsh, it loves the salt marsh, and that's where it lays its eggs, can continue to be part of our landscape. And through the efforts of Mass Audubon and others, terrapins are having a better show of it lately. Other things that are really cool, again, well, the sea lettuce you can see pretty much anytime. That's Ulva lactica. It's one of our seaweeds that obviously carries on photosynthesis. You can find some of this on the beaches sometime that's bleached out. So the green chlorophyll basically leaves it after it's been bleached out. And then on those low tides, you start to get, and that's what this is underneath this sea lettuce. It's got some mud and probably some bryozoans mixed in there too. This is the redbeard sponge that's present along our coast, all along our coast, especially accessible at lower tides. In some of those storm tides we get, in this long rack line, we have some squid eggs here. A rare sighting, but pretty spectacular. There's that hermit crab, and you can see those claws protecting its shell, and then all these little slipper shells around it as well. Other community members that you're going to run into is the famous piping plover, which is doing remarkably better along our Massachusetts coast, thanks to a number of organizations protecting it. To use Duxbury Beach as an example, down here on the South Shore, this year there's been 39 successful nests in that 7-mile stretch, as opposed to 2 years ago where there's 28. And then the least tern is doing better on the Massachusetts coast than it has historically. So things are looking up when we put the energy into it. I can see our time is running out, so I'm going to talk about seaweed a little bit, and then we'll wrap it up. So here is some of the many seaweeds we'll find all along our coast. So here's that sea lettuce. And this is kind of the description of what a lot of seaweed looks like. Some is free floating, but most of it has a hold fast, a stipe, which is basically a trunk, and then the blade. So rockweed, you'll see this bladder wrack and rockweed have these little chambers here. And as a kid, or maybe as an adult, you have found it fun to pop them. What these are, they do a number of things, but primarily they act as air bladders to help keep these blades closer to the surface, so that the plant can enjoy, or the algae can enjoy the benefits of being close to the sun. And then we also recently discovered the amazing ability for kelp, seaweed, and to a similar extent, eelgrass, to trap carbon. Pretty amazing. Another benefit. We're also finding that more and more opportunities are there for raising kelp and other seaweeds for food. And it could be a good pivot for a lot of our folks that live along the coast that have made their living as fisher folk or lobster folk. And as species dwindle, if people are willing to shift over to agriculture, there's some hope and a lot of potential in that. This is sea colander, and this is a seaweed that obviously has been out of the ocean for a while, so it's starting to bleach, but you can see all of the holes and why it has that name, sea colander. So another spot, salt marsh, is great to explore. It's a little different in that it's got the changes of a mud flat to a salt marsh requires freshwater influence. So the freshwater comes down into the system, bringing nutrients and detritus, if you will. And the process of growing this peat, which is this dark organic soil here, takes a long time. So there's very little oxygen in this soil. And because of that, there's the things that grow out here are pretty specialized. So we get essentially some salt marsh hay and Spartina antiflora and Spartina patens. And then we've got these ribbed mussel beds that like salt marshes. They're like our blue mussels that frequent our rocky coastline, but they specialize in growing in salt marshes. Salt marsh sparrows are famous. Their habitat is endangered, and they are becoming much more rare, but there are places that they do well. Our Allen's Pond Sanctuary down in Westport, this spring we had 6 salt marsh sparrows in our sites at once, so that was very encouraging. Famous in the salt marsh and mudflats associated with the salt marsh are fiddler crabs, upper right here, and they have a very large claw that gets them name. It looks like a fiddle, and if they lose that claw, their other claw, their smaller claw will grow bigger, and when during the next molt, the lost claw will come back, but it'll be smaller, so they can be kind of back and forth depending on how many times they've lost their claw. These coffee bean snails amongst here. Here's a close-up of that Spartina patens, or salt meadow hay. This was used a lot by the colonialists to feed livestock. It's often found in the upper reaches of salt marshes. It's not as salt tolerant as its cousin, the antiflora. And here is a willet, one of our few shorebirds, in addition to the piping plover, one of our few shorebirds that nests along the Massachusetts coast. Most of our shorebirds come past, they're not ours, but the ones that we see in the spring and fall are just passing through, going up to the Arctic. But there are a few that nest here, and the willet is one. You can't mistake it. It's a strange shorebird, and that it spends a lot of its time up on top of things. You can see this sitting in trees, on signposts, on osprey nests, once the ospreys have abandoned the nest. And it has a very distinct call and a flashy wing pattern. There's no mistaking it if it's in the air. We'll finish by talking about some places we recommend. And as a Mass Audubon employee, I'm going to concentrate on some of our sanctuaries, but we'll throw in a few others as well. So starting on the North Shore, we've got the Japa Flats, which is close to Plum Island. So these are other places in that area you should you should try out. Plum Island, Parker River National Wildlife Refuge, Crane Beach, Ipswich. In Gloucester, there's a number of things. Singing Beach in Manchester by the Sea, Front Beach in Rockport. As we come down, we're not going to skip over Boston Harbor Islands and Boston Harbor, because that's a spectacular place to do beachcombing and tide pool exploration. So any of the islands in Boston Harbor are great. Revere Beach is a great spot. Spectacle Island, Carson Beach, and Wollaston Beach in Quincy are all fantastic spots. Nantastic Beach in Hull. And then we have a sanctuary called North River that gets you into an estuary. Long pasture down in Barnstable, beautiful barrier beach with big mud flats and salt marsh. Wellfleet Bay is like the jewel of our coastal sanctuaries. A lot going on there. You can get out to Nantucket, Felix Neck in the Vineyard, Great Neck in Wareham, and Allen's Pond in Westport and Dartmouth. But it would be wrong not to talk about some of the other places. Lloyd Center down in this area as well. And any of these beaches along here, Monomoy, Chatham, the outer Cape is just spectacular with the Cape Cod National Seashore, the dunes and coastal forests up in Truro and into Provincetown. Race Point is an amazing place to check out rack lines and maybe get a glimpse of whales off the tip here. Just some incredible spots. But with that, I want to thank you so much for joining us this morning, and I will stop sharing. And Robert, if we've got some questions, happy to. Oh, I'm going to have to turn this back into a.
If you want to leave it up, Doug, you can. It's up to you. But I guess so we do have some questions.
Great.
First question comes from an anonymous attendee who asks, are there guided walks available in any of these protected areas?
Yes. Again, this is going to be self-serving, but because Duxbury Beach is owned by a nonprofit organization, which is a pretty unique situation. It's called the Duxbury Beach Reservation, Inc. And if you can get to the South Shore, they pay us to run free public programs every Tuesday, Thursday, and Saturday from 9:30 to 11. And I do those, and we, depending on the tide, those subjects can be anything. I'm looking at it right now in August. Well, coming up, we're doing piping plovers tomorrow. In August, things like exploring barrier beaches, mud flat limbo, mollusk mania, ABC of tides. We build kites in the very end of the season and talk about the science of flight. Yeah, so if you have the ability to get to the South Shore, there's those. And then there are other, and we have programs. Just check out our website at Mass Audubon. It gets a little confusing. We have so many programs going on, it gets a little hard to navigate. But if you specialize the area you want to check out, I would highly recommend, if you're on the North Shore, looking for programs that Lisa Hutchings does. She is an amazing educator, and she works with all ages, and you'll certainly enjoy presentation from her. There are, I believe, interpreters and people that work in the Boston Harbor Islands that you could join, and they have a pretty significant website as well. But yes.
So Martha is an amateur photographer. She wants to take photos of seals, and she wants to know what's the best place in the state to see sails. I can't even say this. See sails. Where can you watch sails?
Okay, so there's a couple of places that I would recommend. Again, both on the South Shore. You could find them on the North Shore, but they love Manomet, which is the spit of land that comes down off the elbow of the Cape. Yeah, it's down off the elbow of the Cape. A little closer for a lot of folks probably would be in Plymouth, Manomet Point. It's actually where a lot of the humpbacks are being seen recently. And it's basically a cliff. You can access this area and look down on a lot of rocks close in to the shore. And I've been there where I've lost count after 250 individual seals. They're often, if you get to the tide just right, you don't want it to have it too high or they're all be in the water. But if you want to photograph them, then like a mid tide is good. You'll see as soon as some of the rocks are available, so the seal can get up without having to jump too high. So as the tide starts to go down and uncover those rocks, then they start hauling out, and you'll get some great shots.
So we're going to take 5 more minutes of questions here. Marianne says, thank you so much. This was very enjoyable. Diane says, thank you for this presentation. I have seen many of these things on the coast and did not know what they were. Teresa says, thanks for the virtual beachcombing adventure. I learned a lot. Huckfin, not sure if that's a real name, says, thank you, full of wonderful information and a lot of fun. Renee asks, if the horseshoe crab is not a crab, what is it?
It's a arthropod. So it's like related to spiders and scorpions and things like that.
Diane asks, can you talk a little bit about ribbed mussels? I've heard that they should not be eaten because they are very efficient at filtering, and because of that, they are toxic.
Yeah, well, that's a great question. It's more of a any shellfish could be subject to toxins. What's good is that shellfish are similar. So if there is and they're closely monitored. So if they're shutting down shellfish beds for, say, for instance, oysters or clams, then it's a good chance that you shouldn't be eating anything else. Rib mussels have an incredible ability to filter, especially nitrates out of systems. They just don't taste good compared to like blue mussels. Some people they love blue mussels. I haven't heard of anybody that said that they liked rib mussels. They could be eaten, but I think more of I would shy away from them just for that reason alone. But yes, they have a tendency to filter out probably more toxins than others because of their close proximity to the source in the salt marshes. That's not based on any sort of scientific things I've read. That's just based on that's my theory.
Cheryl says, many thanks to you, Doug. Paula echoes those sentiments. Having trouble talking today. Shelley says, is the boring sponge hard or soft?
It's soft.
Shelley with a follow-up question. We're going to do rapid fire here, Doug. We don't have too much time here. Shelley wants to know, can you tell us a little bit more about razor clams? Can you eat them?
Yes, they are. traditionally, so everything kind of comes and goes, you know, with what's kind of what's hip, if you will. But a lot of communities eat razor clams. Yeah, so you get your quahog, which is basically your clam chowder clam. You've got your soft shell clam as your steamers, and oysters, of course. You know, they're famous for cooking them anyway, or not.
Kimberly says, thank you for a great program. And it looks like the last question is going to Zoe, who asks, where are there one tide cycles?
Okay, so areas, there's not a whole lot around here. One of the best examples would be the Vermilion Sea. So the Baja California, the bay is so deep that by the time the second tide would be coming in, the first tide still coming out. So it negates itself, basically. There are other examples of that, but that's kind of the most famous one.
All right, Doug, so it's 12:15. We're going to wrap it there. Thanks so much, Doug. Let's give Doug another big virtual round of applause for being so generous with his time and his knowledge. Folks, look for an email from me tomorrow with a link to a feedback survey, a link to a recording, and some registration information about some other upcoming virtual programs, including one with one of Doug's colleagues next month, who will be talking about how we can better live alongside wildlife. So that'll be coming to you in your inbox tomorrow, so keep an eye on that. Doug, any last words from you?
No, I just hope people have a chance to get out there. Certainly summer has taken a better turn weather-wise, you know. Yeah, love to see you at one of our programs, but also encourage you to do it on your own, because it's still a wonderful experience. And Robert and viewers, I thank you so much for this opportunity.
Great. Thanks so much, Doug. Thank you, everyone. I hope everyone enjoys the rest of their day. Bye-bye.